Hi, I'm Randall Wells with Denver Fire. Today I'm here with Tower 27. We're going to go over a step-by-step process that we utilize for building good habits and muscle memory when training and performing the dash lift. Now we're going to have the crew make this vehicle safe and ready to train. Before we begin our iteration of the dash lift, we're going to have crews remove both these doors. We're going to utilize what we call in Denver the bat wing, better known as a B-post blowout or a total sidewall removal. Now before we do that, we've got to make safe by checking for pre-tensioning devices and also airbags. Companies are going to strip on the clean side of the vehicle, which is opposite of the side where we're working. That way they can look down and visualize and measure and get a precise place to cut without sticking their head inside the vehicle. Now that we've got our doors removed, we're going to start the process of a dash lift. We're going to utilize fluidity of motion between the spreaders and the cutters to achieve our objective. Now, the firefighter on the spreaders is going to step up and remove this fender. When we remove this fender, it gives us a direct observation of the rail and good access to provide that relief cut. In the past, people were taught to either pinch or blindly cut the fender to make that relief. However, what we found is not only are they missing the strut tower, but they're not putting enough of a relief cut into that rail to get an effective dash lift. Once the fender is out of the way, the firefighter on the spreaders is going to tent the hood slightly in front of the hinge mechanism. In training, this simulates a front impact where the hood is already tented and allows the cutter to come in from a top angle, get a direct observation of the location of the strut tower, and make his relief cut effective and completely through the front rail. Now that we've got this area opened up, the cutters can come in from a topward angle and encompass most of the rail with its first cut. We want to ensure that we cut on the passenger compartment side of the strut tower. This also allows us to see how much material is attached to the rail and the strut tower to determine how many cuts we're going to need to completely cut through that support rail. Once our relief cut is made in the support rail, we're going to drop down. Now from the tire side, facing inward on the compartment, we're going to make our first cut. This allows us to make a relief cut in the kickboard, where sometimes there is some substantial amount of material located that can hinder our dash lift. From there, we're going to move the tool slightly perpendicular to the vehicle and overlap our cuts. This will allow us to completely cut through the foundation of the A-pillar. The other thing this prevents is the tool from pulling into the compartment. Once we have these two original cuts made, we'll no longer have the tool pulling into the passenger. made a complete cut through the foundation of the A-pillar. That's what we want. But on occasions, with the type of the vehicle or certain compressions from an accident, we may need to make an additional relief cut in the kickboard. We utilize the reciprocating saw or an air chisel. Now that we've made our relief cuts down low, we're going to come up to the upper portion of the A-pillar and double cut it at roofline. Now, we're going to support the bottom of the A-pillar with some cribbing. We utilize cribbing, not step chocks. That way we have a good flat base to affect our lift. Next, a target of opportunity on our dash lift are the dash tie downs. They connect the tunnel of the vehicle to our dash support rail. They're made of mild steel, but by cutting these, it can affect a huge difference on the travel of our dash lift. We generally have the individual with the air chisel or the reciprocating saw come in from the clean side of the vehicle and try to cut those during our evolution. Now we're ready to perform our dash lift. It's crucial to remember that when we come in perpendicular with the spreaders, we have to be conscious of our backhand. We want it as level as possible because the position of our backhand affects the direction of our lift. Now Tower 27 is going to perform the dash lift evolution like they would at an incident. They'll utilize fluidity of motion between the spreaders, the cutters, and their engineer with the air chisel and reciprocating saw.